In this video, we're going to see how to communicate between an ESP8266 development board and an Arduino Uno. We're going to use the Arduino to collect data from a couple of sensors to measure carbon monoxide and distance. We're going to send the collected data upon request of the ESP8266, which, upon receiving the data, is going to display it on a very simple website. As usual, we'll tinker around with the sensors to see changes and understand how things are working properly. Alright, let's do this! This video is sponsored by JLC PCB. They're currently offering a great deal, just $2 for 10 prototype PCBs with fast turnaround time. They offer a variety of options and the resulting PCBs work great. They also offer stencils, have great facilities and wonderful people, so I encourage you to give them a try. For this video, we're going to be using an Arduino Uno clone and an ESP8266 Node MCU DevKit 1.0. We're going to be using a distance sensor and a carbon monoxide sensor, all of which you can find in my little Amazon shop. After installing the USB drivers, we're going to connect both boards onto my computer using different USB ports. Then I'm going to open an Arduino IDE instance and verify that both USB ports are available. Because I need to work with two boards at once, and to make things easier, I'm going to open up the terminal and use the command open to open a separate Arduino IDE instance that can program the second board. In this second instance, I will select the board for the Node MCU 1.0 and its corresponding port. If you're not sure how to do this, please go ahead and visit my previous videos. I'm going to save this sketch as ESP8266 firmware. Then, on the previous instance of the IDE, I'll go ahead and select the board for the Arduino Uno and its corresponding USB port. I will save the sketch as Uno firmware. Just to test that things are working as expected, I'll go ahead and upload this empty sketch onto my Arduino Uno. When I do that, I should see the Uno's TX and RX LEDs light up. If I try the same thing with the sketch for the ESP8266, I should see the LEDs for that board light up when it's uploading. If everything is working correctly, we can move on to the Arduino Uno side of things. We'll start by installing the Arduino JSON library, and for this video I'll use its latest version, which is 6.10.1. In the sketch, I'll start by including the header file of the library. Then I'll define a couple of variables that I'll use to transmit the data to the ESP8266. In the setup function, I'll initialize the serial communication, and in the loop function, I will monitor the activity on the serial port of the Uno. If there is a message coming through, I will read it into one of my variables, and I will try to process it using the Arduino JSON library. To make things easier, we're going to format the messages using JSON. So using a dynamic JSON document, I will do some basic error checking to make sure that the data is indeed formatted in JSON, and if it is, I'm going to expect it to have a field with the key type, and because that message is going to be sent from the ESP8266 onto the Arduino Uno, it's going to have a value of request. That means that the ESP8266, whenever it requires data, it's going to send a message with that key value pair. If we find that as part of the message, we can construct the response. For that purpose, I'm going to switch the value of the key type to be response. Then I'm going to add two more fields one with the key distance and the value corresponding to the distance measurement, and another with the key gas with the value corresponding to that particular measurement. I can go ahead and upload the code, and if I open up the serial monitor, I can mimic the message that eventually will be sent by the ESP8266 formatted in JSON with the key value pair type request. In the response message, we find a key value pair of type response and the two measurements with the key value pairs distance and a random number, as well as gas with another random number. The random because we haven't connected the sensors just yet. Now we can move on to the ESP8266 side of things. To make things easier, I'm going to go to our repository for this series and use the simple web server sketch as a starting point. I'll leave a link in the description of the video. I'll get rid of things that I won't use, fill in my network ID and password, and use a user-defined function that I'll name handle index to display the data that's collected from the UNO. I'll get rid of the toggle LED function, which we won't use, and because we want the data to also be formatted in JSON, we'll include the header file in our sketch. In the handle index function, we'll send first a request for the data. The dynamic JSON document, as we saw before, will need a key type and a value request in order to get a response from the Arduino UNO. We'll need to make sure that the baud rates used by both ports match. Once that message is sent over serial, we'll get a response. In a similar way that we did on the Arduino UNO, we're going to monitor the serial port for any activity. Notice that this piece of code will block. That means that this while loop will execute while there is data being sent on the serial monitor. The response from the web server will take a little bit of time, but that's okay. Once all the serial data is read, we're going to attempt to deserialize it, assuming that's formatted in JSON. As we did before, we'll do some very basic error checking, and if everything goes well, we should be able to pull the two values that are transmitted from the Arduino UNO, namely the distance and the gas levels. We can then display this data however we want. For this tutorial, I will choose a very simple web page that contains plain text. I will simply use a string variable with the two measurements and the server.send method to display it to the client. With this done, we can move to connecting everything together. The RX pin on the ESP8266 will be connected to the TX pin on the Arduino UNO, and vice versa for the RX pin on the ESP8266. Before connecting the sensors, we can upload the sketch onto the ESP8266 to test the serial communication. If I reset the ESP8266 Node MCU board, it'll connect to my local Wi-Fi network. If I access their root path directory, then the ESP8266 will send a JSON formatted message via the serial port to the Arduino UNO as well as the USB to serial port. So now we're ready to actually hook up the sensors and have some fun. The distance sensor just requires power and the data will be connected to a 0. Similarly, for the carbon monoxide sensor, we'll connect the data pin to A1 and power and ground to 5 volts and ground respectively on the Arduino UNO. Using pretty much any object you think appropriate, you can test out the changes on the distance recorded by the analog sensor. For this quick example, we'll need to refresh the page anytime we want to make a new measurement. as you've seen in my other videos, you can use things like WebSockets, Ajax to make these measurements a little bit more dynamic. For testing carbon monoxide levels, I'll burn a little bit of wood and use just a simple glass vase to contain it around the sensor. If I refresh the page, I also see changes on the carbon monoxide levels that are read by the Arduino Uno and then transmitted to the ESP8266. And there you have it. Very quickly, we were able to use the serial port of an Arduino Uno development board as well as an ESP8266 Node MCU board to send data that's collected by the Arduino Uno to the ESP8266, which, once receiving the data, is able to display it to a client over a web server. If you like my videos, I invite you to my Patreon page where you can chip in a buck or two. That really helps me put in more time into the videos and release them quicker. But whatever you do, don't forget to like, subscribe, or leave me a comment. You can also interact with me on social media. I'm on Instagram, Twitter, and Facebook, and you can even use the community tab of the channel. Thank you for watching my videos, and I will see you next time.